There is a hidden trap with evolutionary solvers, but in this video I will help you understand it and navigate your way around it. A crucial component is going to help us in this mission, and it is the one called Fitness Landscape. It can be found in the Params tab, Util section, next to the Galapagos components. Fitness Landscape can be used to create a 2.5D representation of a dilemma that has two parameters. X and Y will be the planar axles, and the component will create a mesh from the Z values. The component has three inputs: bounds, values, and count. A rectangle is connected to the bounds input, and it will act as the base and the borders that the landscape will be built on top of. I have used a simple rectangle component to create this. Values input will take a flattened list of the fitness values. Here I have 100 values. Count input will tell us how many of the fitness values in a row will there be in the x-axis. Remember that the number of items in values input must be divisible by the number inputted to count. 100 items is divisible by 10. I will turn on numbering. I have used annotation dots to display the values at mesh points. I have a series of values from 1 to 100. When the count is set to 10, we will have 10 values in x direction, and the rest are distributed along the y direction. I will go to top view, and here you can see how the values form a grid. In this case, the fitness landscape slowly ascends towards the end until it reaches the highest Z value, which is 100. Here is an example of a fitness landscape. The function it represents has 4 local maximums, one of them also being the global maximum. This is a very low quality local maximum, but with a large basin. This means that the fitness that spawns in its basin will likely evolve towards here. Then there are 2 equally good but still low quality maxims. Their basins are of a little different shape but can easily lead the evolution towards an unwanted direction. There is only one solution that is the absolute greatest. This is the global maximum. The evolution will be easier to understand if we flip the values to the negative side. Now imagine that you are dropping a ball randomly on the area. It will have to land very close to the global maximum to be guided to the peak value. If it lands off by even the smallest amount, it will roll towards the local optima. Like the ball, evolution will also go towards better fitness. The fitness landscape also has multiple view options. You can use blank display, an elevation display, which will help us identify the peaks, a basin display, which can help us separate the different basins, feature display, and slope display, and direction display. We can also add some contours to help visualize how rapidly the values change in the landscape. You can also bake the landscape, and you will save the colors to the mesh. Now the key takeaway from this video is that if you are using evolutionary solving, you have to have enough values, because, for example, in a fitness landscape like this, you will not find the global maximum if there is not enough randomization to hit a value in this basin. That is all for now. If you learned something, hit the like button and subscribe to the channel.